Yeah, so I'm going to present the benchmarking of evaporator cleaning practices at Louisiana factories in 2020. So during the 2020 Louisiana grinding season, 10 Louisiana factories were visited in order to collect information about evaporator cleaning practices. All the information that you see here is the information that we collect from each factory. We collect evaporator characteristics such as the number of evaporators, the evaporator's evaporation surface area, the tube's material, tube diameter. About operation parameters, we collect information about the cane to throughput rate, the exhausted steam pressure, the operating temperatures and pressures, lime juice and clarified juice pH, juice and syrup bricks, and all the information about the cleaning practices that I'm going to show in the next slides. So the results that we got from this information is the next information. So first, I'm going to talk about the evaporator characteristics. So here in the blue box, you can see the area of each factory. In this case, we have the area from the 11 factories. And on the orange line, you can see the final evaporator syrup bricks. We can say that the evaporation area average in Louisiana factories is around 0.16 square feet per ton of cane. There were no relationship between the final evaporator syrup bricks and the evaporation area. You can see here evaporators area, a low evaporation area with a low bricks, but we can see here factories with the same area and with higher bricks. So it could be another factors like the target that the factory needs for the boiling process. It could be the kind of scale that they are using that could affect the evaporation efficiency, and it could be another parameters that affect the final evaporator syrup bricks. Here we can see the tube material of each evaporator. So in all the Louisiana factories, and we found that 67% of the evaporator tubes are made of copper, and 33% of the evaporators are made of stainless steel. About the evaporator cleaning frequency, so we can say that 10 of the factories determine when cleaning is required at regular intervals. You can see here that most of the factories use regular intervals. The average frequency is between 9 to 11 days. In most of the cases, the determination of the exact day of the cleaning depends on the operation efficiency. So if they are notice a low final syrup bricks, they are going to accelerate the cleaning process. We also noticed that factory 4 is the only factory that is using heat transfer coefficient as a measure of the cleaning efficiency. So they are not using HTC as to determine when they are going to clean the evaporators. They are using HTC only to qualify the efficiency of the cleaning process. So they know how much is the maximum HTC that they obtain with the evaporators. And after the cleaning, they measure this coefficient and they know the difference of the cleaning process. Here, I'm going to explain like the common chemical cleaning procedure here in Louisiana. So first, they drain the evaporators vessels. Then they rinse with water. Some of them fill the evaporator with water, and another factories spray the water inside the evaporator. Then most of the factories boil caustic soda first. Then they rinse the caustic soda. Then they boil the acid. And finally, they rinse again the acid to start with the evaporation process. So now 9 of 10 factories rinse the evaporator after the caustic soda and the acid treatment, and just one of the factories don't rinse the evaporator at all. So they boil the caustic soda, they boil the acid, and they put the juice again. So they don't rinse the evaporator. 4 factories rinse the evaporator by spraying the water. So they have some sprays at the top of the evaporator and they spray the water inside. And 5 factories rinse them by filling the evaporators to 100% of the tube's level, and then they just discharge that water. 9 of them factories boil caustic soda and then the acid. Just one factory does the opposite. So they boil first the acid and then they boil the caustic soda. 8 of them factories boil the chemicals with exhausted steam, which is an indirect contact heating, and they also add water to maintain the level of the chemicals inside the evaporator. 2 factories boil the chemicals with high pressure steam injection, and they use jet nozzles to do that injection, and this is a direct contact heating. So they are adding water with the steam, so they don't need to add additional water to maintain the level of the chemicals inside the evaporators. Those are the results of the caustic soda and acids concentration that they are using inside the evaporators. So the most common caustic soda dosage concentration is between 20 to 25%. Here you can see that most of the factories have the same, around the same concentration. Just one factory, which is the factory 8, use a lower concentration around 12%. All factories use hydrochloric acid for cleaning evaporator with copper tubes. The most common chemical for cleaning evaporator with the stainless steel tubes is phosphoric acid. EVAPA is used in one factory for cleaning all the evaporators, and another factory uses EVAPA for cleaning only the last effect. So here you can see the concentration of the hydrochloric acid that most of the factories are using. And here I want to point out that just one factory is using hydrochloric acid, and they are adding also ammonium bifluoride to improve the cleaning performance. And this is the dosage concentration of phosphoric acid, EVAPA, and sulfamic acid. So the dosage concentration of those acids are really variable. We are going to do some tests here in Audubon to test to evaluate which is the best concentration of caustic soda and acids to remove the escape from the evaporators. Here I'm going to talk about the boiling time and temperature. So on this side, on this table, you can see the boiling temperature of each chemical, and on this side, you can see the boiling time. So caustic soda boiling temperature is commonly around 220 Fahrenheit. However, 2 factories boil the caustic soda in the last effects at lowest temperature. You can see here in the factory 11, and you also can see it here in factory 1. Some authors report a minimum temperature of 212 Fahrenheit to have a great cleaning process with caustic soda. Caustic soda boiling times are highly variable. Here you can see that the minimum time that they are boiling caustic soda, like in factory A, is around 1 hour, but there is another factory that boil the caustic soda for 6 hours, so this is highly variable. The acid boiling temperature in most of the factories is close to the inhibitor maximum recommended temperature, which is around 220 Fahrenheit. You can see here the temperature is almost the same in all the factories, and the boiling time is almost the same too, around 1 to 2 hours. Here I'm going to talk about the chemicals consumption. So in the factories with the lowest chemical consumption, which are the factory 1, 8, 10, and 11, all the operators have copper tubes, which was really particular when I noticed that. And factory 3 is the exception because this factory also have a low consumption of chemicals, and this factory have only 64% of the tubes are made of copper, which was really particular to unique. Yeah. Factory 8 has another unique thing, is that this factory is the factory that boils first the acid and then they boil the caustic soda, which means that this practice is not affecting the performance of the cleaning process because this factory is also having a low chemical consumption. There are no clear reasons for the relatively high chemical consumption of some factories like 2, 4, 5, 6, and 9. We are going to do further analysis because we are going to take a scale sample. We are going to try to take a scale sample from most of the factories, and we are going to characterize that scale to try to understand why this is happening. About the cleaning performance inspection. So we know that 4 of the factories don't inspect at all the evaporator after the cleaning process. They just finish the evaporator process, they put juice again, and that's it. 3 factories do a visual inspection. So they open the manhole, they see in the top of the tubes, they see with a flashlight what they can see, and that's it. 3 factories have camera, which is a boroscope camera, and they could inspect the tubes of the evaporator. But only one of those factories is using the boroscope regularly after every cleaning process. This is the boroscope camera, and this is a video of this factory, which is the factory 4. And this is a video of one tube after the caustic soda boiling. So they can check if the caustic soda boiling treatment was enough, or if they need more time with caustic soda. They can notice the scale, the appearance of the scale. So this is a scale here. You can see that you can remove it easily. So this is the way that they determine that they are going to boil then the acid and how long they are going to boil the acid. Because as you can see here, you can see a soft scale in this case. And after that, this is a video after the acid treatment, and you can see that there is not a scale at all. So it was a good treatment in this case. Something really unique about this factory is the factory 4. They always check the cleaning performance, but they also have one of the highest consumption of chemicals. So we want to try to analyze why this is happening with the scale samples that we are going to take. As conclusions, I can say that 10 of the factories determine when cleaning is required at regular intervals. The normal intervals is between 9 to 11 days. The common cleaning process in Louisiana factories is to boil caustic soda and then boil acid. 9 of them factories are doing this, and just 1 factory is doing the opposite. All factories use caustic soda as a basic treatment. The most common caustic soda dosage concentration is between 20 to 25%. And the most common caustic soda boiling temperature is around 220 Fahrenheit. The caustic soda boiling time is highly variable, as I said. It could be 1 hour to 6 hours. All the factories use hydrochloric acid for cleaning evaporator with copper tubes. The most common chemical for cleaning evaporator with stainless steel tubes is phosphoric acid. 1 factory is using also EVTA for cleaning all the evaporators, and another factory is using EVTA for cleaning just the last effect, because they say it's the hardest scale to remove. In the factories with the lowest consumption of chemicals, all evaporators have copper tubes. There are no clear reasons for the relatively high chemicals consumption of some factories, so further analysis will be done after scale characterization. And the next study that we are going to do is we are going to evaluate the chemical dosage concentration here at Autopump. So we are going to visit all the factories to try to collect the scale samples and tube with the scale if that's possible, to test different combination, different temperature, different concentration, to try to figure out which is the best treatment to remove scale from the evaporators. I just want to say thanks to the American Sugarcane League for partial funding for this project, and I also want to thanks to the factory staff for all their help. And thank you so much.
Well, y'all have done a great job of playing past the keyboard and switch presenters, so thank y'all very much. I'm looking, I have no question in the chat. If I get anything, I will pass it on within chat to one of you. And Collins, I will pass the microphone to you, sir.